Hello, and welcome to the Repast group here at Florida Polytechnic University. Today we're going to go over Demo 00, Step 01. And so I already have the guide pulled up here from their website, the Repast HPC tutorial. Demo 00, Step 01, Hello World program. This is a simple program. You can see it right here. All it does is it has one include, a main function, and a simple printf function called that says hello world. So we're going to minimize this for now. We'll pull up my SSH secure shell on one end and my nifty notepad document on the other with all my notes in it. And when we're doing anything in the Repast HPC tutorial, we're going to want to do it in the work folder. So here on the right, you can see that in my SSH secure shell that I'm in my home directory right now, /home/QuentinGoss0323, and we want to be in our source folder and in our work folder. So we'll navigate to our source folder. So here I am in my source folder. Now we're going to want to go in our work folder, but we'll take a peek in the Repast HPC folder here. And peeking in here, we can see that we have the 5 demos, 0 through 4. This is where all the source code is. If for any reason we have to go in and modify any of the source code, we're going to go into this folder and then into the respective folders thereafter. So we don't need to go in there for now, so we're just going to navigate over to our work folder and clear up the screen, and here we are in the work folder. We can see that by printing the working directory. Now in this work folder, we have 3 other folders: bin, objects, output, and we have 2 files, env and makefile. But we're not going to touch any of these right now. We're probably not going to touch any of these until step 1, so don't worry about it. So the first command that we're going to look at over here, you're going to love this command. This is going to make your life so much easier in this tutorial. It's the make copy command. The structure of it here, I'll describe the structure as we type it out, but it's going to be this one right here in my notes. So first we're going to type in make, M-A-K-E, followed by a single space. This lets our supercomputer operating system know that we want to use a command in this make file here. So the command we're going to use is copy _ repast HPC, capital R, E-P-A-S-T, capital HPC, _ demo, capital D-E-M-O, _ followed by whichever demo that we're on, and we're on demo 00, so we're going to type in 00, followed by an underscore, and then step, capital S-T-E-P, _ 00, and we're going to make sure this is correct, demo 00, step 00, press enter. And that was not correct. I don't know why I did. I don't know why I did step 00. We are on step 1. Oops. So this is what it looks like when you type it in correctly. You can see that this make file also cleans out some of the unnecessary files in your work directory with all these remove commands. And it copies over a single file. We'll clean up the screen and look in our folder, and we have this new thing here called demo _00.cpp. We'll look in this real quick using nano. So nano space, demo00. We can start typing in the first couple of letters and then press tab, and bash will automatically fill in our command. So we can see here, if we compare this CPP file to the one in the tutorial, we can see that it's the same thing. And so we'll exit the file, clear up the screen, and now we have to compile the file, now we have to compile our CPP file. And to do this, we are going to use MPICC. They need to be capital, the 2 capital C's for C++ on our particular computer. And then we're going to use -O, which means that we're going to make an output or a .o file. And then we want whatever the name of the .o file is going to be. So we're going to call it demo_00.o to keep the naming convention of the tutorial. And then we're going to have a space, and we're going to include the file that we want to compile, which is the CPP file. So capital DEMO_00.cpp, followed by a space, and we don't need these flags right now, but we'll type them in anyways. Minus capital W and O minus deprecated, followed by a space, minus std equals A++11. And let's make sure that compiled properly. If it compiled properly, you'll see a .o called demo_00.o, and that's what we want. Oh, after we compile it, we're going to have to submit the job to the supercomputer. And your supercomputer, how you submit the commands to your supercomputer is probably not going to be the same, but general structure of the command is going to be similar. On our particular computer, we use bsub, and so that's what we're going to use throughout the tutorial. So here we're going to type in bsub, so that Unix knows what we're using. Then -n, followed by a single space, and then a 10. It doesn't have to be 10, we can use 7 if we really want to. This is just the amount of processors that we're requesting to run our program on. So we're going to use 10. And a minus, a capital R, followed by a single space, and then an open quotation, span, and square bracket, tile equals 1, and square bracket, and quotations, followed by a single space. We're going to use a -O flag for the -O file, and then single space %J .out, and we want it to display our output in a .out file. Then we're going to have to locate mpyrun. You're either going to have to figure it out yourself by going into your shared files in your supercomputer, or ask whoever administers your supercomputer where mpyrun is. So ours is in /opt/IBM /platform_MPI /bin/mpy run. And we're going to use two flags, -lsf and -bapi. After this, we have to locate where our program is that we're going to submit, and we could just do demo _00.o with the dot there, since it's in the same folder, but for good practice we're going to specify the entire path of it. So it's in our home directory and my directory, in my particular home directory, GOS0323. It's in our source folder, and within that it's in the work folder, and then we have demo _00.o. We're going to end with a semicolon and a wait. Then we close the quotation and we submit. Now we can see here job 4912 is submitted to the default queue and medium priority. We type in bjobs to see if there's any jobs running. There's no unfinished jobs running, so we can assume that job 4912 is going to be in our working directory, which is the file that we're in. We'll check it using ls, and we can see here that indeed we have 4912.out, which is our output file. So let's check this out real quick using nano, N-A-N-O, followed by a single space, 4912.out. And we'll look through this too. We can see CPU time took 0.79 seconds. And something went wrong here. Alright, we have a garbled mess of stuff that went wrong, but hey, everybody's perfect, right? Probably messed up something in the, aha, yes, here we go. I forgot the E in my name. So we'll exit out of this real quick, and we'll ls to display everything. I'm going to remove the output file since it's useless now, and do ls again. Then I'm going to correct my problem. Now, this is a very good example of why you should save all of your commands in plain text in a file somewhere. I already have these all written out in this wonderful repast.txt notepad document, so I'm just going to copy this whole bsub command over and then put it into the Unix using shift insert, and all that command that we typed out, it's right there. I'll submit it again, check bjobs, no unfinished job found. I'll look in my folder, I can see 4913, and so I'll view 4913 using nano. Here we go. We can see that the CPU time took 0.78 seconds. We can also see hello world. Don't worry if you see MPI application rank 0 exited before MPI init, or MPI application rank 2 killed. That just means that we had 10 processors, but the first one that we ran the hello world program on completed, and all the other processors didn't have time to run the program before the first one ended. So as long as you see hello world at least once, it might be 3 or 4 or even 10 times, that means that your program's worked. And that concludes Demo 00 Step 1. Stay tuned for more videos from the Repast group here at Florida Polytechnic. Demo 00 Step 02 is going to be out shortly.